Right, welcome back. What I want to do this morning is to look at measurement of power in a three-phase system. Okay. Now, measurement of power in a three-phase system. Power in three-phase circuits can be measured by using either 1, 2, or 3 watt meters. Okay. Now, check your information. Don't take this just as read. Do some background research for yourself. Make sure that you understand the concepts of line 1, line 2, and line 3 in regards to the three-phase systems. Okay. Some people will have a different method of calculations in regards to watt meters and so forth. But look at something from a guy called Blondell as well, I believe. Okay. And quite a number of others. See how they have approached it, use their information, see what you can learn from it. Expand your own learning requirements and expectations. Okay. And here's our watt meter. Single phase watt meter method. The measurement of power in a star connected balance load using 1 watt meter in circuit is shown in figure 4.20. Okay. Single phase. But we have line 1, line 2, and line 3. Okay. This is only used as an illustration. Now remember to look at how the domestic watt meter has been used and how that is connected, and I believe I have got some information on here already, so just look it up on my channel if you wish. Okay, or do your own background research to make sure you understand the full concept of the meters. Okay, the watt meter current coil is connected in one line, and the voltage coil is connected between the line and the neutral. Okay. Remember, your center point is your neutral point, or your earth point if you prefer, but that would be your neutral point. Okay. The reading on the watt meter gives the power per phase. Okay. So total power PT equals 3 times watt meter reading. Okay. And because you're looking at a three-phase system here, in regards to line 1, line 2, line 3, it is only showing you the power in one phase at this point in time, not all 3 phases. Okay. Now here we have B, 2 watt meter method. The measurement of power in a star connected balance load using 2 watt meters is illustrated in figure 4.21. And here we have our 2 watt meter system. Okay. One watt meter WB and second watt meter WY. Okay. And please note that we're using here system red, yellow, blue, but this is no longer the color for the three-phase system. So please make sure you apply the up-to-date references in regards to red, yellow, blue. I believe they're now black, gray, something or the other. Okay, that this is now important for you to look up and make sure that you're using the correct references in regards to our phasing. Okay, know your phase correct colors because it's applicable in the UK and it is in Europe. That I don't think they will change, irrespective of we leaving the European Union. Okay. Now here it gives us voltage across WB, and make sure you're looking at WB. So where's WB? WB is here. Okay, that's WB. All right, that's WY. Okay, make sure you know which is which in this case, but remember you can change this to modify and reflect today's correct phases of colors. Okay, but the principle remains the same. It has not changed. Voltage across WB equals VBN minus VRN. Instantaneous power equals PB equals IB VBN minus VRN. Voltage across WY equals VYN minus VRN. Okay? Instantaneous power PY equals IY VYN minus VRN. Okay? And these are just a formulation of application for you to know and be familiar with. Now, each of these gives you a formula to find the relevant total power. Okay, I'm not going to do anything more on that, but leave that for you to delve into a bit more deeper for yourselves. Okay. Now here we have the expression IB, voltage across WB, represents the reading on the wattmeter WB, and the expression IY, voltage across WY, represents the reading on wattmeter WY. This method of power measurement is suitable for balanced and non-balanced loads on star or delta connected loads. To determine the power factor, the following formula can be used. And here we're looking for the power factor, which is the angle at which they intersect each other. And you need a good power factor to have efficiency. And normally that power factor is approximately 0.9. Okay? And then this is just your formula. Remember, square root of 3, etc. You can read that for yourself. Don't need me to read that out to you. Okay. 3 wattmeter method, a 4-wire star connected load using 3 wattmeters, and here you have 1, 2, 3. Okay. Using a similar analysis, so that in the 2 wattmeter method, it can be shown that the total power PT is the sum of the individual wattmeter readings. So total power equals WB plus WR plus WY. And here we have an examples of. The input power to a 3-phase motor was measured by 2 wattmeters method, given readings of 7.2 kilowatts and 2.8 kilowatts. Determine the total power. Okay, 7.2 kilowatts. And here we have minus 2.8 kilowatts. Okay. Equals 4.4 kilowatts. And that is a simple process that's been applied here. Okay. Here, a 3-phase 550 volt star connected induction motor has an output of 34 kilowatts with an efficiency of 85% and a power factor of 0.9. Now it has a good power factor. Calculate the input power and estimate the readings of 2 wattmeters that are connected to measure the input power. Output power equals 34 kilowatts. Efficiency equals 85%, which equals to 0.85. Cos theta, I call it cos theta, equals 0.9. Now here 0.9 could be leading or lagging depending on what components are being used. Here we have efficiency equals output power over input power. Input power equals output power over efficiency. And here we have our formulation here being applied to this. Okay. Now normally I would write this as 34 times 10 to the 3 over 0.85, and you'll see that's 40 kilowatts. If you So let me just see if I can get, hang on, sorry, let me see if I can get a marker here, a pen here. Sorry, no, I can't get a marker on my system at the moment. I'm not in the right system. So, okay, but you can see here, remember that is 34,000, okay? Not just 34, because it's 34K. That comes from here. That is that there, okay? 0.85 is your percentage ratio of efficiency, I should say. Okay. Okay, and here you have your W1 plus W2 equals 40. Okay, put it into your formulation here. Okay, and we know we have 0.9. Cos theta. Okay, now type in 0.9 in the calculator, then press shift to get you this is just to show you how you got 0.4841. okay, it comes at 0.4842 because I think it was rounded up. Okay, and then here we have your formulation. Now remember, this is over the square root of 3, and just confirm that the square root of 3 is equal to 1.732. You need to confirm this for yourself. Okay, it's important that you know how to do this, and that then comes into this place here. W1 plus W2, we know it's 40 already, and that is our angle from here. Okay, well, from here. Okay, this is the idea. This one here is rounded up a bit close, but if you have a different calculator, you'll find that it will round up even more precisely. But don't worry about that, that's close enough for us to work with. Okay, like this gives us 11.8. Okay, sorry, 11.18, my apologies, sorry. Okay, here we are looking now at W1 plus W2 equals 40, W1 minus W2 equals 11.18. So here we have equation 1, equation 2, okay? Add equation 1 to equation 2. Now here from equation 1, we have W2 equals 40 minus W1, and we have W2 equals 40 minus 25.59. And if you look back at this here carefully, if you look at this here, W1 25.59, take that from 40K, and then we take W2, yeah, sorry, let me just make sure that I look at this piece in correct. correctly, and if I'm talking, it's okay. When I move down, I always lose my position, so do excuse me for a moment. Okay. Yes, it's okay. When you add equation 1 and equation 2, it gives you 51.18, okay? Then we are subtracting here, okay? That leaves us 14.41. Now again here, I want you to determine that 14.41 is the correct value for yourselves, okay? Make sure you know how we got it, okay? And here we have the input power is 40 kilowatts with wattmeter reading of 25.59 kilowatts and 14.41 kilowatts, okay? Okay, and that's just for now, okay? Again, this is just for your information. Hopefully you found this to be useful. Let me just go back, make sure that I get it all in place and all of you. And again, have a good day. Thank you for watching, and we'll continue with our little snippets, okay? Just making sure that it's all in. So, thank you, bye-bye.